So as continuations of our representing function yesterday, I want to talk about linear functions specifically. So here it is. Linear function. So I want to focus your attention into this word. The word is linear. Okay, so every time I say linear, the first thing that comes to your mind is straight. If I graph a line and it doesn't look straight to you, you did something wrong. Or if I plot points and I said, hey, graph this linear function, and your points look like this. And you try to say, wait, that's not a straight line. So you know that something is wrong with your calculation. That's a good hint. Okay? Because when I ask you to do a linear function, I expect that when you connect all of your points, you should see a straight line. Okay? And that's the beauty of a linear function. Now, the first part of a linear function is, how do you actually recognize it to be a linear function to begin with? What does it have to look like to be called a linear function? Okay? So I just want to point out a couple things that's very important for you to recognize that something is a linear function. Here's some characteristics of a linear function. Of linear. Okay? First of all, you will see that the x and y terms, or should I say the input and output terms, so this is the input, and this is the output terms, they all have first degree power. Now, what does it mean to say first degree power? It means this: if I write an x, it's just going to be an x. If I write a y, it's just going to be a y. It's not going to be x squared, y cubed, because that is not first degree, because this is second degree, so that's third degree. So you will just see x and y. That's it. Okay? There's no such thing as second degree or second power or third power, fourth power. No, it's not like that. Or square. No squaring, no cube or anything like that. Just x or y. Okay? Or x and y together. So that's the first characteristic that you should know about. Second thing is that you will never see the x and y connected together by a multiplication. They should be separated by plus or minus sign, or should be separated somehow. They're not going to be linked up. So they're not going to be linked up. They're separated. I think I spelled it wrong, huh? Separated. Yeah. By plus or minus. So for instance, it looks like this. Notice, x and y's are separated by a plus sign. You never see a linear function looking like this. Never. Because x and y is not separated by a plus or minus, it's separated by a division. Not allowed. And you will never see a linear function looking like this. What do you see? Yeah, it's linked up by a multiplication sign and not plus or minus. So once again, not correct. Okay? Let me ask you this question then. Is this a linear function? What about, is that a linear function? Think carefully before you say it.
No.
You said no. Let me prove it to you. Can we move y over? Yes. How? Subtract. So is it a linear function now? It is. See that? Because guess what? It's separated by a minus sign or a plus, right? But if it looks like that, it doesn't mean it's not, right? You can still move it over and still make it look like one. Okay? So let me introduce now what we call is a standard function. If you can take any equation and turn it back into a standard function and it looks like this, you know for sure that it is a linear function. So the third one I want to talk about is called a standard form. It has to look in its standard form. So the standard form of a linear function will look like this, where a, b, c's are just regular numbers, regular integers, I should say. it is. As long as you can take any equation and turn it back into like this, you know for sure it's a linear function. Okay? Now, let me just say something. It doesn't always look like that, but still, it fits as a linear function as well. And so I'm going to talk to you about two special cases that you need to learn. Okay? And those cases are this. So first case, first special case, when your linear function looks, or I should say, your line looks like this. Watch. So here's two special cases I want to talk about. If I ever ask you to graph, and you need to decide, well, is that a linear function or not? It's actually a good idea to graph this to see for yourself. But notice that for this particular equation, what's missing? The y. What about the other one? The x. So what it really means is, whatever y is, I don't really care. All that I care about is that the x will stay 5s all the time. So you can throw me anything for y. The x will always stay as a 5. There it is. So let's throw me some y value. 0, 1, 2, 3. So notice, if this thing's fixated, x will always be 5. Over here, what it tells you, the y will always be 5. So that means I don't care what x you throw at me. My y value will always be a 5. So 0, 1, 2, 3, for example. There. So if you plot this, I'm trying to prove for yourself here. Let's plot. 5, 0. 1, 2, 3, 4, 5, 0. 5, 1, which is right here, right? 5, 2, right here. 5, 3, right here. 5, 4, right here. We agree? And if we connect them, we'll see ourselves a straight line. Okay? So that's for this graph. Over here, if I do the same exact thing, what you see is 0, 5. So 1, 2, 3, 4, 5 right there. 1, 5 right here. 2, 5. 3, 5. 4, 5. If I connect these, I will see a what line? Horizontal. And the other line is what? Vertical. Okay. First of all, they're both straight lines. But remember we talked about validating a function? How many ways do we test a function? About the cheating stuff, remember? 3 ways. But since we already have the graph up here, what's the best way to test it? The VLT, vertical line test. So let's test it. Will this line pass the vertical line test?
No.
Will it pass over every one point at a time?
Yeah.
If you draw a vertical line? Yes. So because of that, this is actually a linear function. It works. Horizontal line works. So this is a function. Over here, will it pass the vertical line test? No. Why? Yeah, if you actually draw a vertical line right through these, it will cross over every single point. Because of that, this is not a function. But why do I have to bring this up? Because there are technically special cases in our linear graphing. They're both straight lines. But one is a function while the other one is not. Okay? But when I say a linear function, it has to pass the vertical line test. Okay? But if I just want to graph a linear graph, it could be a straight line, but it doesn't necessarily pass the linear function test. Okay? So these are the two cases that I need you to remember by heart. Because if you don't recognize them, you will not be able to say, oh wait, that's a vertical line graph. If I graph it, this is a horizontal line graph. Yes?
Can you explain what the vertical line test is?
Oh, what it means is, it tests for cheating, basically. Okay? Remember about the part where I said one number cannot be giving two different, cannot cheat on 2 different numbers? The vertical line test will show you that. If one number is actually cheating on 2 other numbers, you will see that the vertical line test will cross over more than 2 points at a time. Like this one right here. Notice that 5 is going with 0, 5, 1, 5, 2. It's cheating with 4 other points. That's why the vertical line tests show that it's crossing over at 4 points. That's what it means. Okay. Any question on that part? Are we clear on what a linear function is, how to recognize it, and so special cases of linear function and what's not?
Yeah.
Okay. Now, this is the easy stuff. I mean, you understand it. It's great stuff. I wanted, yesterday I kind of I already showed this yesterday, but I figure it's best if I show it to you again. if I show you this particular one and ask you, hey guys, can you make this into a table and graph this line for me? By the way, is that linear function? Is that linear to begin with? Yes. If I want you to graph this equation, how do you make it into a table to graph? Think about that for a moment. What do you have to do to prepare for graphing? Can you graph it in the current state? The answer is yes, but not now. What we learned right now is we cannot graph it in its current state, and we have to prepare for it. And the way that we prepare for it is by isolating the what? The variable. Which variable has to be isolated? The y, the output, isn't it? Did you notice from yesterday? It's always going to be output equals to something. Output equal to something. Is that true? So therefore, to prepare this for graphing, or to put it into a table, you gotta isolate your. Notice I don't want you to use y because I could use other variable, but I want to use the term output. Isolate your output. So in this case, we kind of learned by heart that y is the output and x the input, right? So let's solve for y. How do I solve for y? What do you do? Minus 2x over. Good, because remember 3 is attached to y, so that's the last thing to go. 2x is farther away. Let's get rid of it. So by moving the whole term over, I subtract it over. I end up with 3y equals to negative 2x equals to, plus 6, right? Agree? Next. Divided by 3. Divided by 3. Divided by 3. Notice when I divide by 3, I divide every single term by 3. So then y equals to negative 2/3 x plus 2. So I got myself an equation, right? Now, at this point, if you'd like to turn it to a function notation, if I ask you to, you can. I can write like this as a function notation. F of x, which is f function taking the x, and it's going to process it by multiply by 2/3 plus 2. Right? If I want to convert it back to a function notation. If I don't ask you to, you don't have to. You can leave it in its current state and then set up a table for it. So let's set up a table. I know we don't have room for it. Let me just go ahead and copy that over here so I know what to use. Okay, watch this. Let's set up a table. The table we set up yesterday include the input. The input will go through the machines, right? Which will process it by taking the input times it by negative 2/3 plus 2. Agree with that? And then what does it spit out?
The
Output. And then once you have the output, you put together the input and output to form a point. There. This is called what we call a 4-column style table. Input. What does it do to the input? It'll give you back an output. Put your input and output together to form a point. So let's process. Here's some couple rules that I want to remind you when you choose your own inputs. First of all, choose numbers that are small enough to process. You don't want to pick 1,000, 1,542. Doesn't make sense. So pick small numbers. Secondly, what else? What do you think? When it's involved fractions like this, what do you want to pick? What kind of number should you pick so that it's easier to multiply into negative 2/3? Multiple of the denominator, which is 3, 6, 9. You see that? So whenever you have fractions in your table and you want to process easily, choose numbers that are multiples of your denominator. So I would always start off with this, to be honest. 0. Why? Why do I choose 0? Yeah, anything times 0 is 0. So for example, negative 2/3 times 0, you know it's going to be 0, so the answer is just going to be 2. That's like a giveaway. Easy stuff. And automatically my next point is going to be what? 3. Not 1. Why not 1? Is 1 a multiple of 3? No. But 3 is. So if you take that, watch what happened. What is 3 times negative 2? Divided by 3? Or you can cross divide, right? 3 divided by 3 is 1 times negative 2 is negative 2. What's negative 2 plus 2?
0.
You see how easy that is? So I don't want you to be afraid of seeing a fraction in your problem. All you need to care about is picking the multiple of the denominator. Okay, what do you think another point to pick here? 6. It's okay to pick on the negative side too if you want. It doesn't matter. But 6, so negative 2/3 times 6 plus 2. What is the answer here? Okay, it is -4 plus 2. -2. Very good. Okay, 6 divided by 3 is 2. 2 times -2 is -4 plus 2. The winner is the negative, so therefore you end up with that. Okay, so how many points do I want on your table? Minimum? 3. It's good enough. Okay, just have 3 points and we're done. We're set. We'll put together input and output. 0, 2. We have 3 and 0. We have 6 and -2. Please ask me right now if you have any questions on how to set up your table. We're good, right? And then I just plot these points. Watch this. First point, 0, 2. So 0, nowhere in the horizontal, but 2 up. 3, 0, so I'm going to go 3 to the right and nowhere up. And 6, -2, so 3, 4, 5, 6. And then -2 is going to be down here, so it's going to look something like this. And notice, I know my points are a little off, but you can still see that they will indeed give you a straight line where you connect them. That's how you know you did it correctly. So let's say that when you've done solving, you plot the points and your point's all crooked, you need to go back to your table and see what you did wrong in calculations. That is the only error, really. Okay? But that's how you graph a line using a table format. This is called 4-column style table. Any questions at all? I'll stop right now and show you another method, okay guys?